Hi, this is Ms. Cho on how to factor quadratic expressions by grouping. This is a method that works best when your leading coefficient or your A term is greater than 1. The big idea with factoring by grouping is that you're going to rewrite a quadratic expression from a trinomial with 3 terms to an equivalent one with 4 terms, except that you're going to break up the B term into 2 smaller terms so that you can form smaller groups and factor using the GCF. So you can do that several times until you get to a final answer, which is a product, something in factored form. Let's take a look at an example. In this example, we have y is equal to 3x squared minus 5x plus 2. The first thing we're going to do is to factor out a GCF if there is one. Since 3, 5, and 2 do not have a common factor, we can move on to the next step. Next, I'm going to multiply a and c, which is 3 times 2, which gives me 6, and I'm going to list the factors. So to get positive 6, I can multiply positive 1, positive 6, negative 1, negative 6, positive 2, positive 3, and negative 2, negative 3. I'm looking for a pair of factors that adds up to b. In this case, my b is negative 5. And so the only way that I can add them to get negative 5 is to have a negative 2 and a negative 3. Once I have the pair of factors that adds up to b, I'm going to rewrite my trinomial in 4 terms. So 3x squared minus 5x plus 2 becomes 3x squared minus 2x minus 3x plus 2, because then minus 2x and a minus 3x add up to minus 5x. From there, I can make 2 groups, and then I will want to find the GCF of each group. So then in my first group, my greatest common factor is an x. To find out what's remaining, I'm going to divide all my terms by x. 3x squared divided by x is 3x, negative 2x divided by x is minus 2. In my second term, I see a minus here, so I'm going to drop that down. And then my greatest common factor is 1, because 3 and 2 don't have common factors. I'm going to divide by negative 1 to find what's left inside. So negative 3x divided by negative 1 is positive 3x. A positive 2 divided by negative 1 is minus 2. Here, I have 2 terms that are the same. This is a common factor. This is like saying if I had x times a minus 1 times a, I could factor out the a, and I could rewrite this as x minus 1. So instead of an a, we have a 3x minus 2. So that is our new greatest common factor. So I can rewrite this as 3x minus 2 as my factor, and what is left is an x minus 1, which is my final step to rewrite as a product of 2 factors. Let's try a second example. In this example, we have y is equal to 4x squared minus 2x minus 42. So 1, I'm going to factor out the GCF. I see that all my numbers are even, so I can factor out a 2. This leaves me with 2x squared minus x minus 21. In step 2, I multiply a and c and find factors. A is 2. C is negative 21, so my AC is equal to negative 42, and my factors are 1 and 42, 2 and 21, 3 and 14, and 6 and 7. In my step 3, I'm looking for a pair that adds to B. My B now is negative 1. No combination of 1 and 42 can give me a negative 1 or any of the others. The only one is a 6 and a 7. In step 4, I rewrite my trinomial as 4 terms. Don't forget the GCF. So I'm just going to copy the A and the C, and then I'm going to rewrite 6x and 7x. In order for me to have a negative x, I know that the 7 has to be negative and the 6 has to be positive. In my 5th step, I make 2 groups, and then I find the GCF. So I'm going to recopy the 2, the big GCF, and then in 2x squared plus 6x have a common factor of 2x. To find out what's left, I can divide each term by 2x. This leaves me with x and plus 3. I see the negative here, so I drop that. And then my common factor of 7x and 21 is 7. I divide each term by -7. -7x divided by -7 gives me a positive x. -21 divided by -7 is a positive 3. Now, in step 6, I'm going to use GCF again. My GCF is now x plus 3. And then what's left is 2x minus 7. Be careful. If these two terms don't match, you cannot factor it out. You cannot move on. It just means that this problem can't be factored by grouping, and you can use a different method. But if they are the same, if they match, you can pull it out as a common factor, and you have your new product. To summarize, when you factor by grouping, you factor out the GCF of the whole expression if there is one. Then you multiply A and C, and you list the factors. You choose the pair that adds to B. You rewrite your trinomial as 4 terms using the pair of factors you found that adds up to B. You factor out the GCF in each group, and you repeat that until you have a product of factors. If you're not sure if you factored correctly, you can check in 2 ways. One is algebraic. You multiply out all your factors and see if you get the same expression back. And the second is you graph. You can graph your standard form, and you can graph your factored forms right on top of each other and see if your graphs are the same.